Welcome to qnawire.
This is problem number 52 of the Stewart Calculus 8th edition, section 2.8. The figure shows the graphs of four functions. One is the position function of a car, one is the velocity of the car, one is its acceleration, and one is its jerk. Identify each curve and explain your choices. So here we have our graph where it shows all four curves, A, B, C, and D. And we're just going to start, let's say, with curve D and see what we can determine from discussing the derivative of each function. So if we look at curve D, it is always increasing. If this curve is always increasing, its derivative must only be above the x-axis, so only positive. Um, and we see that this is only true of graph C, because curve A and B, they have negative parts, meaning that there's no way that a curve A and curve B can describe the ever-increasing um, derivative of D, or the ever-increasing nature, behavior of D. So curve C must be the derivative of curve D. Curve C itself is all increasing up until it gets to this point here, where it maxes out, small minimum, maximum. Afterward, it just slightly decreases. So we need a function that's mostly positive. Here we see B is mostly positive. A has a negative region here. A is negative here, which would not correspond with this behavior of C. So B is mostly positive, and then at the point here, it looks like it lines up perfectly with the maximum of C, and then afterwards B is slightly negative, corresponding to the decrease here after its maximum. So it looks like B is the derivative of C, and then we recall again C was the derivative of D. So far, it seems like everything's pretty consistent. We look at curve B, it has a maximum here, meaning that its derivative should cross the x-axis here, and A is the only line that does that. So the A curve must be the derivative of B. And then we know that B is increasing up until its maximum, so its derivative must have positive values, which we see from curve A. And then afterwards, B is always decreasing. So afterwards, the derivative of B must have all negative values, which is true here, shown after A crosses the x-axis. So A must be the derivative of B, and then B was also the derivative of C, and C is the derivative of D. So in order, D must be the position function of the car, since it's the first function. D is the position function. C is the velocity, or C is the velocity function, since it's the derivative of D. B is the acceleration function, and it's the derivative of acceleration. And A is the jerk function, jerk meaning the derivative of acceleration. Jerk is the term used to describe the derivative of acceleration. And so all of these curves, of these choices were confirmed by investigating and analyzing the graph.